Hello, my name is Mason Anderson, and this is my Unit 12 project for college algebra. In this video, I'm going to be solving a linear programming problem that I found on qmath.com, and I'm going to be solving this linear programming problem by graphing. So the first thing I'm going to do is I'm going to write our objective function for this linear program problem. So our objective function is going to be z is equal to 2x plus 5y. Now, linear programming problems have restrictions. They are also known as constraints. So I'm going to list my constraints as inequalities, and then after that I'm going to change them into equations. So my constraints are x plus 4y is less than or equal to 24. My second constraint is 3x plus y, which is less than or equal to 21. And my third constraint is going to be x plus y, which is less than or equal to 9. And this is where x is going to be greater than or equal to 0, and y is going to be greater than or equal to 0. So as I previously stated, I'm going to change these inequalities into equations, which is quite simple. So this is going to change into x plus 4y equals 24, 3x plus y equals 21, and x plus y equals 9. Just making sure you can see that there. Okay. Now, the next step after doing that would be to plot your lines. For the sake of time, I actually plotted my lines ahead of time. So let me explain these lines. So we have x plus 4y equals 24. So that line crosses through 0, 6. So we have 0, 6, and then 24, 0. My next equation, 3x plus y equals 21, passes through 0, 21, and 7, 0. So 7, 0 down here. Okay. My third equation, x plus y equals 9, passes through 9, 0, passes through 9, 0, and 0, 9. So we have 0, 9 here, 9, 0 here, okay? All right. So, as you can see, when we plot our lines, we have this region here. So, we're going to find our corner points. Our corner points are going to be, we're going to find our corner points of this region. So they're going to be 0, 0, 7, 0, 6, 3, 4, 5, and 0, 6. Now remember, we're trying to find the maximum point. So in order to do that, we just need to substitute these corner points back into our objective function. So remember, our objective function was 2x plus 5y. And just as an example, I'll show you how to substitute that back in there. So you're going to have 2 7 plus 5 times 0. And obviously, when you do that, you'll get 14. And when you substitute these corner points back into your equation, you should get for 0, 0, 0, for 7, 0, 14, for 6, 3, 27, for 4, 5, 33, and for 0, 6, 30. Now, 33 is the maximum value. So, we know our solution set is going to be x equals 4 and y equals 5.